Welcome back to session 2 of the morning. I hope you're all enjoying yourselves. And if you're not, I don't know, keep it to yourself or something. I'm going to just hand over directly to Zain, who's going to talk to us about found font family.
Hello, everyone. This is a bit of a talk that I threw together because I ended up working with fonts a lot. I was a front-end engineer. I am still a front-end engineer, which turns out that fonts matter aggressively, more so than in any other software engineering profession. And I never really understood them. So I put together a little talk explaining it, and after a couple of cycles of revision, I've arrived at what is effectively a 20-minute rant and a little bit of a fever dream. And I'd like you to come on this journey with me. Let's start with the problem. Have you ever used this little VS Code Pets extension? It's adorable, would recommend, and it means that you can have a little cat or a dog or a pet, and it just dances around in the bottom left of your screen while you code, gives you the moral support to get through those long, long days. And it's very adorable, and I want it in my terminal, desperately. I need it. However, there is a little problem I ran into. Terminals don't print images. You can find GPU accelerated ones that do it, but for the most part, I couldn't get a terminal to just output an image, which is weird to me. Because I feel like a browser, if there's one thing a browser does, is it shows you pictures of cats. Maybe too much, frankly. And there was no good way to do it in the terminal. So I kind of began my journey here. If I wanted a cute Tamagotchi-style cat in my terminal, how am I going to make that happen? So, first of all, I tried to look at different ways that you could render images to the terminal. There are some programs that do it. They do a lot of this. They do a lot of ASCII art. They try and approximate every pixel to an ASCII character or a text character and print it out. And the reason for this is sort of this fundamental limitation of terminals, is that they really only work with text. If you want to be clever and have any sort of graphics, everything on screen has to be a character, a printable character that your font renderer, or your text renderer, better said, can handle. So that means that we're kind of limited here in what we can do. However, this led me down a little journey. What even is text? What even is something that a text renderer can render? Because I've seen Python code, and in Python code you can use little accents above the E. There's a pi symbol. That's not a classical character, but it renders fine. It works. You can print that out to most terminals. They'll handle it. So, where can we go with this? We begin with a little bit of a fundamental understanding. Computers don't know anything, basically, at all, but they do know numbers. Also, sometimes not numbers. Don't talk about floating points. And you can assign every glyph. I'm going to use the word glyph. Effectively, I mean like a text character, but we'll talk a little bit later about why I have broadened it to the term glyph. And it assigns it to a number. The character A is 65. There's a long history here about why it's 65, but we're just going to trust that it's 65. And all the font renderer does, or text renderer, is it renders that character to screen. Now, there are other things that you can put into code and put into any area that accepts text, basically anything that renders Unicode, such as an emoji. And if you print the value of it in the same way that A is 65, this little onigiri, which is not a donut, is 127833. So all it is, really, is a mapping of number to glyph. And the glyph is because it can be a character, it can be an emoji, it can be a little pi symbol, it can be really basically anything. But no, it can't be anything. It has to be something that it can support. But this led me to this wonderful realization. We have images. You can print emojis to the terminal. Who has used any CLI application created in the last 5 years? They're chocked full of it. Every time npm installs something, it'll give you a little emoji. It'll give you a pretty little terminal output. So you can use emojis. Is this the solution? Which led me to a little question. Can I add another emoji? Can I just add emojis? Someone's adding them. There's more now than there were 5 years ago, right? I'd like to play a little game with you as a little demonstration. Can people have a guess at what these 3 emojis are called in the official Unicode spec? You're onto it already, but yeah, very close. But you might assume siren. You might assume police siren, right? What about the second one? I call this the yikes face, personally. Grimacing teeth? You guys are all nerds. What about the last one? Someone said steam, yeah. Well, I would say angry or very angry, but it is police car revolving light, grimacing face, face with steam from nose. Now, these seem well, practically useless for if I am trying to search for an emoji to send to someone, because I search by emotion, frankly, as I imagine most people in this room would do. But the issue is that the Unicode spec is not going to stop today. It is hopefully going to last for decades in the future. So there is basically a trend to not put too much context into these words. Like, grimacing face is a direct analysis of what this is. Police car's roving light is. Siren maybe wouldn't be, right? That actually is context dependent. Maybe in the future, after an apocalypse, everyone uses the red light to actually mean something completely different. Maybe it's an everything is okay alarm, you know? So this kind of reveals something important about Unicode, is that it has to survive. And there's a nice little example. Does anyone know what emoji this is? Pager. I have asked this to groups of younger people, and they cannot answer. And understandably so. I think aside from maybe hospitals, there's no real use case for a pager anymore. And yet, not only will the emoji persist, it'll persist indefinitely. Because Unicode is not just for now. It is universal. I believe that's what the uni in Unicode stands for. Probably should have looked that up. And the point there is that we can't just add emojis. We have to have a real reason to put them in and a real backing for why they need to exist long term. Which is why we have a consortium. One of the most powerful tools, and yet one of the most boring tools, is a bunch of people sitting around making very small decisions with a lot of consensus, but incredibly important because we get Unicode out of it. And, oh, that's crazy. It's a static slide. It's an offline presentation. I'm just going to try again, and hopefully that goes through. Anyway, the next slide is basically going to be talking a little bit about how you get an emoji in. It takes an average of 2 years, and it is unbelievable. Again, I downloaded the whole thing. Anyway, this is another rant I could go on about the state of current software. It takes about 2 years for an emoji to go from proposal up until implementation. And I guess, what can I do other than continuously refresh? I'm going to turn my phone again. Yeah, 2 years. And also, the funniest thing, which is what I was going to show you, is that there's official proposals. There's documents that people write to say, I would like this emoji to exist. And they're hilariously funny to read, because it is very serious. They have graphs, they have justifications, they have sort orders, but it is about an emoji. And I would love to show you an example. I'm gonna fingers crossed, and I'm also going to hotspot. Oh, this is terrible. It worked for the first 5 slides. It lulled me into a full sense of confidence. Okay. Anyway. I'm hotspotting now. Nope. Oh, there's also no reception here, of course. I was warned about this, which is why I tested it offline, but apparently it might just cache the first 5 slides, so when I went through the first 5, I thought it was going to be fine.
The core network works all right.
The core network?
The core. The guest network. And you just scroll down and say, give me slow Wi-Fi without my details, and it's fast.
Is that through, is this one of the... It's not on my list. Oh, ACCOR, yep, got it.
It'll need you to go through a bunch of stuff.
Yep, were you going to hotspot me? Or? I'm currently going through your core stuff.
Mine's called... No. Okay, it's called Spot.
Sorry, guys, hold.
It did work until just now when we told everyone in the room.
Okay, see if you can find me. It's called Spot.
Oh, there you go.
Password is
Yeah, stop it. Anyway, thank you so much for putting up with this. Sorry, guys.
Call out your favorite emoji. Yes.
Oh, 100% yikes. I use that every day in every situation. Oh, sorry, grimacing face. Okay, we're going to try this thing one more time. Hey! Thank you so much to our speaker, absolute legend. Okay, I have time. I might go a little bit faster. Anyway, yes, it takes lots of time. This slide was mostly because I love this little section where it goes, no, I'm not going to make you dinner, and then it nods, which I think is kind of funny. And oftentimes how I've been using that, get out of my way, nod. It's very funny. Anyway, look, point is, this is more of an aside, but the point is that there is hard to put an emoji in. But we're beginning to get somewhere. Because we have this concept of a number, and we have this concept of something that can get printed to the screen, and it seems like the terminal already has that going. So can we inject some code in the middle? This is a lot of how I do software engineering. So there is something called a font renderer or a text renderer, which does something with the number to actually print it to screen. Can I inject something in there? And actually, this led me to my next realization, which is, what is actually, taking a step back, what's up with all these emojis? Why do they render differently on different platforms? Like, the whole point of a Unicode consortium, like creating all these emojis, is that they're standardized, right? So like, why is it that on iOS, for some reason, it has an extra sticker on it, but on Google, no such snippet information is stuck on the box, not compliant. And Samsung just has a blank one, and then WhatsApp, for some reason, switches it, and also isn't fragile. What does it say about Google that their emoji is fragile, but none of the other ones are? Think about it. But the fundamental question here is, why are they different? And I would like to rephrase this problem to you. Is this actually that weird? Single character 65 renders differently in different fonts. Also, you should go to like Google Fonts and just look through some of the font names. They get pretty crazy as like the less popular you go. I love Just Me Again down here. Because try to use that in a casual conversation of like, what font should I use? Anyway, so that's effectively how you can control the rendering of certain characters. And actually, that's the missing piece here, is that a font renderer doesn't just render a single number to a glyph. It actually takes in a font, and the font helps describe, in fact, it completely describes how each character is rendered. So maybe all we need to do is make a font. 65 can map to all of these different types of characters. Why could it not map to something more interesting? Now, whose terminal looks like this? Blank, default settings. Classic, respect. Whose terminal looks like this? Yeah, little power line. When you set this up, did you have to install something called like an icon font? Very much so. Yeah, and that kind of was another hint of like, okay, well, surely there is a way to get a bunch of arbitrary images into a font, because I did it when I set up my terminal to be nice and pretty. You'll see my terminal later. I think it is very pretty. And can we then co-opt this method to get some kitties, right? Okay, so we've arrived at the point in the talk where all we have to do, very easily, very quickly, is make a font with some kitties in it. How hard could it be? How hard could it be? Let's start super simple. When you're doing software engineering, you break the problem down as much as you can. Bitmap fonts. These are actually what every font was back in ye olde days. It's very simple. Every character is just a little image. It's a bitmap, to be specific. It is literally, here is how big the character is, and here's every pixel that needs to be filled. And this works fine. Maybe we can just use this method. But it does have an, oh, can everyone read that really easily? No? Let me zoom in on it. Oh, ugh. Yeah, kind of ugly, huh? Yeah, turns out bitmap fonts don't scale very well. Obviously, earlier computers, you only really had like one text size, that's fine. But once we started adding more, we just generated more bitmap fonts. Someone would hand draw every character in multiple different sizes. That's how we dealt with it. But in today's age, maybe you have a user who needs accessibility needs and wants to really pump up the screen size, sorry, the font size. Maybe you have someone who's a power user and wants as much text possible on their screen at one point, and they want to make it small. You kind of need to support an arbitrary amount of font sizes. So that doesn't work for us. I want my kitty to render in all possible sizes. So this is a little demonstration of why this happens. Effectively, if I have one pixel on the left and I'm trying to map it to a new resolution, I believe actually the last slide, that's fine. Oh yeah, last slide, that's like 1.75 times bigger, which is important, because if it was an exact power of 2, it would actually easily scale, yeah. But in this one, you can see it's sort of like half supposed to be covering some. There's many different ways you can handle this. Most text renderers go for this approach, where you blur across different pixels, and it's ugly. I don't like it. So what about vector fonts? Oh yeah, I forgot to put that in there. Yeah, busy, I know her. Vector fonts are kind of an amazing concept, and I would like to spend a little bit of time talking about them because I think they're a phenomenal way to solve this problem. But effectively, what if instead of encoding every single pixel, we encoded the vibes? And A kind of looks like this. And if you put a little bit of more rigor into that, you come up with vector formats. If you've ever worked with SVG, this should probably be quite familiar. But effectively, you have a little pen, and you tell the pen where to go. And the nice thing about this, actually, let's go through a little example. Here's a little pen. I've moved it to the pixel 1.4. I can then draw a line to 1.8. Note that I didn't actually say fill in the pixels between these 2 points. I just say draw to this point. And then I can even do curves. In the appendix is a link to a video by Freya, who explains how Bezier curves work. It is a phenomenal video, but it is very complicated. Bezier curves are actually a whole field of mathematics, so I'm not going to talk about them here. But trust, you can just curve mathematically, deterministically. And then you can scale this up. And the nice thing is because we've stored not pixel information, but instructions, you can scale this up with arbitrary resolutions. And suddenly, you have smooth lines no matter what the screen size is. So here's a little video. I think I took this from R.L. Hugh. Yep, this is a very cool YouTube video he made about how fonts work. And you can see how, line by line, with a little pen, you can draw a G. Isn't that awesome? So how do I do this? I went online. There's a beautiful community of open source artists who like to give out assets for free, like with full licensing, and I love that. This one's Elton. He also has paid sprites. If you need sprites, maybe check him out. And I stole this little one. I say stole, took with licensing, and I converted it into a little font. I took each pixel, pixel art cat, and I just filled it in with black. Fonts don't have to be monochromatic. It helps if they are. It makes it easier. And I made this little asset. You can actually see this little one is from the same sprite sheet. Cool, let's make it. But there's one question we need to answer. What Unicode character do we give the kitty, right? We can't just chuck it in. It needs something to reference it. Well, I said, whatever, E. What could go wrong? Oh, no.
Suspense builds.
Oh, that's funny. That's fine. It's going to work. I'm going to reconnect to this. I think the PyCon Wi-Fi network slightly loaded again, and it went back. Yeah. OK, sure. OK. Yeah, I try to run it, and I just get an E out. Actually, oh, that is annoying. This was going to be a lot more of a funnier joke with like I was going to do a setup for it, but I will. Can you all give me a polite laugh? Thank you. Thank you very much. Oh, and the applause. Oh, please, guys. Yeah, OK, well, for whatever reason, it's not working. And this brings us to an interesting problem of how do we actually get the font to work? Now, I threw this image in because I did a practice run of this talk with a friend. And as I was explaining to him how operating systems do font resolution, he was like, oh, yeah, like Swiss cheese. And I looked at him blankly, and he went, oh, yeah, because like every glyph goes through multiple different fonts until it gets a hit. Kind of like if you layered Swiss cheese on top of each other. And I'm going to be... Thank you. I really just wanted to say that because I thought it was funny more than anything else. Another way to look at it is like this, where the major takeaway here is that whenever you're rendering a piece of text, you don't actually render it like sentence by sentence or word by word. You render it glyph by glyph. So every single letter in a sentence goes through and checks for what font do I have installed that tells me how to render this. So most fonts don't actually have the full Unicode like set in it. There's a lot of characters in the Unicode set, and for the most part, if I was making a font, it would be ridiculous for me to draw every possible character in like the Arabic alphabet, especially if I'm not planning to use the Arabic alphabet. So what your browser will do is it'll go through an order, and it will check each font until it hits one of them that can render the character. So you can see here, H actually isn't defined in, let's say, this hypothetical Japanese font, or in this icon font, but it is in this font called the Patramono, which is the font I use for this. It's one of my favorite fonts. Then the next one is in the first Japanese font, so it hits and it renders correctly, and same thing with the icon font. And this is nice. It means we can actually make a font with literally exactly 4 characters in it, which are the 4 sprites I want for my cat, and I can just install it. And as long as I make sure that there's no clashes, it'll always work, which is really nice. And we don't have to worry about also designing like a cat version of H and E and L and L. So, oh, right, yeah, OK. So I've installed it correctly. But if you remember, we bound it to E. So now every time an E pops up, a little kitty comes. But I will say, I kind of love this. I almost left it. But no, let's do this properly. How do those icon fonts work? They don't have any issues rendering the icons with other text, right? And it's because the Unicode Consortium, in their endless mercy, have given us a block, actually several blocks, called private use blocks. Basically, they go, here's a block of Unicode characters, use them for whatever you want. They can't ensure that 2 different fonts you've downloaded off the internet don't both use the same Unicode point in the private use, but they are promising that the core consortium will never use these. These are like free to use. But it is funny because then every single icon font you download uses the same range, so actually they still fight with each other. But I'm going to use this. And it's a little kitty. That's it. You install it on your operating system? Oh, thank you. Thank you. This took weeks. Anyway, I'm skimming over a lot of the complexities of actually making a font. It is horrific. If anyone is interested in font making, maybe don't. No, I'm kidding. It's just very complicated, and the tooling is quite intense. But you have a little kitty now, and it works fine. Isn't that beautiful? So now the question comes, can I make it move? I don't want this little kitty to just sit there and be pretty, as much as it is. I want it to move, maybe eat an apple, you know? Be a little Tamagotchi. So this comes into the next chapter 3 of this talk, which is, how far can we push this? Turns out, pretty far. People have actually been using fonts to imitate motion for a while. So there's a little font that comes pre-installed on Windows computers called Miro Boot. Does anyone feel like this little loader is familiar at all? Yeah, it's the Windows 10, I believe, or 11 loader, which specifically usually pops up when you've blue screened of death to your computer, which I did several times. And yeah, it turns out that in that environment, I mean, I guess I'm not an engineer at Windows, so I can't guarantee this. But my assumption is that in that environment, it was easier to just put these glyphs into the font and then just update the text every like half a second to get the desired effect than it was to import a full video renderer or like a GIF renderer or GIF. And it allows you to sort of like circumvent a lot of code by just leveraging something that you have to set up a text renderer on every screen anyway. If you want to render text to the user, you set up a text renderer. And then you can just kind of piggyback off of that instead of having to do extra work. But effectively, not very complicated. It's just a sprite sheet. If we have any like people who know the lingo from the game dev community, you can have individual glyphs and you just cycle through them. So fonts can be sprite sheets. Here's what I've done. 4 exactly. Actually, there's a 5th kitty that I'll show you later. That they're very subtle. The tail is wagging up and down. It's very simple. And all I've done is I put this into the font, and then I wrote a Python program to just cycle through each of those characters. I think I did like every half a second. Right? Isn't it adorable? Yeah. Look at it go. So yeah, that allows us to give motion. And since you can move where the character is in a certain block of text, it could also walk around. You could change its walking animation. You could do a lot here. In fact, could we run Doom, do you reckon? I don't know. I think it could be possible. But no, I did briefly consider pivoting this talk hard into how I could run Doom through a font. And I did. I got a little into it, but no, it turned out to be a huge undertaking, sadly, because I don't think you can compile C to a font yet. So instead, I've thought about what else I can use. What else kind of features of a font can I leverage here to give me more functionality? And one thing I wanted was if 2 kitties are on the screen and they get close to each other, I want them to hold hands. Very simple. And I could do this by just detecting when 2 kitties are close to each other and then replacing them. Why would I? That's ridiculous. Have you heard about multi-character ligatures? This is this cool system where if you're a programmer and you use, I think Firo Code is the most popular font that does this. If you have 2 equal signs next to each other, it combines them into a single nice, pretty glyph. Same with like a bunch of other ones. And also, and I have a little caveat here. This isn't technically a multi-character ligature in like the implementation of it, but there's something called ZWJ emoji sequences, which stands for zero width joiner, which is if you have an emoji, a special glue character, and another emoji, the font renderer reads that as one block, combines them, and then produces a different glyph. So a lot of emojis that we use are actually combinations of existing emojis. For example, I believe man and holding hand are 2 men holding hands. Makes sense. Yeah, so can we leverage this to our advantage? I would like to say this alone took me hours, because the way that you have to define them in the font files is actually surprisingly complicated, but... Oh, sorry. Actually, you know what? Let's jump forward. I want to show you this. I want to show you it working. Cute. So this other slide is actually because I was thinking about what are the actual use cases for this other than multi-character ligatures and making the kitties hold hands. Also, you can see that because of the way that the character works, it had to like reduce the size. But that's okay, because they're scalable vector graphics, and we could scale it back up. But yeah, so other examples of this, and one of my favorite ones, is that if you download like Google's product font and you type in Google logo, that is a multi-character ligature that then gets replaced with like a high-resolution logo. Yeah, which I thought was kind of cool. So there's actually a lot of power here. If there's one thing I'd like you to take away from this talk is that you can push fonts pretty far, and it might be an unusual or an unexpected solution to a problem you've run into. The Miro boot example I think, is a very fun one. But there's a bunch of other examples, I don't have time to mention them all, where I've seen people use fonts quite cleverly to solve problems. And the purpose of this talk mostly is to be like, hey, that's a thing that can happen. So we have little kitties, they're holding hands. Now, this is officially the end of my talk. If you'd like to applause, you can. But since I have 5 minutes left, I might do one appendix slide, and then we'll move on, because there's one other thing I want to mention, which is variable fonts. So the concept of a font has actually evolved, and in the same way that we now have this nice ability for a single font file to be able to render a character at any arbitrary font size, that's awesome. Why can't we do that with font weight? If anyone has actually downloaded a font family, it's usually like 7 copies for each font weight, usually like semi-black, black, bold, light, regular. So variable fonts are kind of a solution to this, and they allow you to define in the font file an axis, and the axis can be basically anything. The spec is actually very loose, but practically you mostly use it for things like font weight is now arbitrarily renderable. You store instructions on how to render the thickness of a stroke differently depending on this axis variable. You can do it here. I believe this one is, yep, like a standard. You can see that it's also non-linear. The middle of the S gets fatter as you sort of slide it to the right faster than the slide goes. This one's very cool. This is a space-filling one. So as you sort of expand it, it'll take up more and more space. The character fundamentally changes how it renders and the points it renders against, which is very cool. And I forget what this last one was doing. And because this is a GIF, I just have to like patiently wait for it to cycle back around. See? Also very cool. Oh, I never get there. Anyway, it's fine. Point is that this is actually probably, like if I was going to make Doom in a font, this is probably where I would begin with an axis for time and see how far I could push it. But this is a cool future iteration. Maybe the most important of which is being optical size, where if you're rendering at a small size, you actually want to change the way your character renders almost entirely to maximize for legibility. Whereas if you're rendering as like a huge heading, you can kind of be a lot more interesting and cursive and play around with your glyph a lot more. So this gives you a way to do that. That's about it. Here's a little link to the video if you want to watch Freya's video on Bezier curves. Thank you. Thank you for the Wi-Fi.
Thank you. I think that was the most useful talk I've seen at this conference so far. Stuff phylogenetics.
Stop it.
Okay. I'm sorry. I think we have time for one question. Yes. Do we have a room monitor?
Where can I download the kitty font?
I will upload it to GitHub, but it is exactly the 5 glyphs.
I don't care. I still want it.
I will upload it to GitHub. I got you.
Good,
I'll post it
thank
to
you.
Discord.
Thank you. That was the correct question. Thanks, everyone. 10-minute break. Please be here for the next talk, which is Benno ranting about something or other.